Hey guys, and welcome to your Thursday, November 9th lesson. Today we're going to be working on naming and writing formulas for covalent compounds. Just a quick reminder before we continue, we do have a part 1 quiz coming up on Monday that's going to cover the content that we worked on yesterday on Wednesday over the properties of covalent bonds and over electronegativity, including today's work that we're going to do. Okay, so just a quick reminder there. All right, so we're going to go ahead and get started here. You're going to be following along in your notes with me, and we're on naming covalent compounds. So we have our binary molecules that we're going to be naming. There are bigger molecules with covalent than just binary, but we're going to be focusing on just those. Remember, the prefix bi means two, so that's two capital letters or two elements involved. As we learned yesterday, the covalent compounds are all going to be non-metals, both our first one and our second one. So we have our steps that we're going to go through here. Step number 1, and we're using N2O as our compound for an example. So number 1, we have the first element in our formula is named first. So whatever you see first is what you're going to write first. So we're going to use its whole name. We're going to pick nitrogen as our example here, as our very first one there. And so we just give it its full name. Step number 2, we're going to go ahead and pick our second element. Oops, sorry, didn't mean to go backwards there. Our second element, and we're going to give it its root IDE, just like we saw before. Oh, sorry, I keep pushing buttons. And so O is going to turn into an oxide for us. The third step, this is the new thing. So step 1 and step 2 should sound pretty familiar compared to what we've done in the past. But step 3 is where we're going to start using what we call prefixes. And those prefixes are used to tell us how many atoms of each element are present in the compound. So as you guys remember yesterday, there are no ions in a covalent compound, so there's no way for us to tell what's going on as far as the charges to be able to say how many of each I need, because everything is neutral, right? So what we're doing here is we're recognizing quantity this time. And by doing that, it's going to allow us to use prefixes, and that's going to be helping us to identify the amount. So for example, I have 2 atoms of nitrogen, and therefore I'm going to use the prefix di. All right, I have 1 atom of oxygen, and so I'm going to use the prefix mono. All right, and so in front of nitrogen, I put the di prefix to indicate those 2. And in front of oxide, I put mono to represent the 1. Okay, and it's literally as easy as it sounds. Now, be careful, because a lot of students, once we introduce prefixes, they want to stick a prefix on everything, and we cannot do that. So this is literally just covalent. Okay, all right, let me go ahead and clear screen, and we're going to go ahead and move forward. So I'm going to let you take a minute, and I'm going to let you write down all of our prefixes that we are utilizing. So 1 is mono, as we've seen already. 2 is di. Excuse me, I'm a little bit tired tonight. 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta. Be careful with those two. They're very similar. Keep in mind a hexagon is a number 6. Shaped, sorry, my brain is gone for a minute. It's a 6-sided ring for a hexagon. Hepta 7, 8 octa, 9 nona, and 10 deca. If you do not have these all filled in yet, go ahead and pause it and do that for me real quick. Okay. So we're going to do some practice with naming. I want you to pause the video and I want you to try these real quickly on your own based on the rules that we just looked at. All right. And then unpause it and let's check to see how you did. So I'm going to go ahead and get started with naming here. So here we have our first element of nitrogen, and our second element is hydrogen, and we call that hydride. Okay. And then we're going to go back and we're going to fill in our prefixes. Now, we do not say mono whenever we're doing our first element as a singleton. It's unnecessary. So we don't need the word mono in front on this particular one. But we do need to recognize that there's 3 hydrogens. So we're going to call this trihydride. Okay. Nitrogen trihydride on this particular one. Okay. There we go, nice and pretty. Next, we're going to look at this one here. So our first element is sulfur, so we're going to call it what it is. And I'm sorry, my handwriting's pretty rough, but it's not easy to write on these electric pads, so sorry. Our second element is chlorine. We're going to turn that into chloride. And so once again, I'm not going to need that mono in front of sulfur. It's assumed if I don't say it on here. But I am going to recognize that 2 on chlorine, and so we're going to call this dichloride. Sulfur dichloride on that particular one. Hopefully you guys are seeing that these are pretty easy in comparison to what we were doing in the covalent unit, in the ionic unit before. All right, so this next one, F2, this one's a little different. There's just 2 fluorine atoms bonded together. So we actually have a couple of different ways we can name this. You can name this as what we call diatomic fluorine. Okay, or you can call it fluoride. Either one is fine. Just be careful not to call it a fluoride ion because it is not an ion. It is simply a neutral set of fluorine atoms that are going to be bonded together. I prefer diatomic fluorine. So anytime you see your elements that are going to bond to each other and that's it, you can go ahead and call it diatomic and whatever that one's called. Fluorine, chlorine, bromine, whatever. The last one here, we're going to go ahead and break this one down. My first element is carbon. We're going to just write it as is, nothing changed. And then once again, I'm going to use chlorine as my second element. So we're going to call that chloride. Okay, so hopefully this is a little reinforcement that that IDE ending goes for just one element. That rang true all through ionic, and now it is also true for covalent. Okay, so common thread there. Here we're going to use a 4 prefix to recognize that we have 4 chlorines. We're going to call this tetra. Okay, carbon tetrachloride would be the final name for that one. All right, so we'll go ahead and put that up there. Make sure that you are spelling correctly and that yours look like mine. Okay, so I'm going to have you pause again, and I want you to try these on your own, and let's see how it goes. Okay, hopefully you paused it and you tried it yourself. We're actually just going to be walking ourselves through these again. N nitrogen, there's two of them, so I'm going to call this dinitrogen. And oxygen, I only have one of them, so I'm going to call it monoxide. All right, monoxide sounds a little silly, so we drop one of the vowels in the name of it. Okay, so we call this dinitrogen monoxide. Next one phosphorus, so I would just name it phosphorus. 3 chlorines, so that would be trichloride. Phosphorus, trichloride. Whoops, I've got an error here. Hold on, let me fix that. Okay, and we're back. Let's go ahead and try that again. All right, phosphorus trichloride, as we said before. This next one is just like the fluorine we saw on the last page, so we're going to call this bromide or diatomic bromine. And our last one here, a little bit more challenging. This time we're going to use arsenic as our AS, and then there's 4 of them, so we would call that tetra arsenic. And then 10 oxygens, and if you look back on those prefixes, that would be decaoxide. 10 for my oxygen, and then once again, as you saw on the monoxide, we dropped one of the vowels. We're going to do the same thing over here. We're going to call it decoxide, okay? Tetraarsenic decoxide would be the name of that one, okay? And that's really all there is to naming these, guys. It's super easy. It's way less complicated than doing the ionic stuff, which is why I knew you could handle this lesson without me being there. All right, so we're going to go ahead and we're going to switch gears and we're going to work the other way around next. All right, so here we have naming to formula. So now that you understand how the naming works, this should be a piece of cake for us. So let me go ahead and get my pen ready. So this next one, we're going to go with the formula. So the first one is boron. So we literally would just write a B for boron. There's no prefix, so it's an understood 1. We don't have to write it. And then trichloride. So that would be Cl for chlorine. And then remember that prefix is going to give me a 3. And it's super easy. It's so fast, guys. All right, the next one, silicon dioxide. Silicon is Si. No prefix in front. So I keep going. Dioxide, as we've seen already, that's going to be an O and 2 subscript. Okay, please make sure that these are all subscripts, not superscripts. Okay, not numbers up top, not in the middle, but at the bottom. All right, next one, carbon tetrachloride. Carbon, no prefix in front. Move on. Chloride is the root of my name here. That's chlorine, so we'll put another Cl here. And then tetra, that prefix is going to be a 4. So CCl4. All right, you've gotten 3 examples here. Go ahead and pause it and try to work these next 3 on your own, and then I'll just go and make sure you've got them right. Okay, so next we're looking at sulfur dioxide. That should be an SO2. Check your work, make sure you got it right. Nitrogen monoxide, that would be literally NO. That's it, just NO. Diphosphorus pentoxide, diphosphorus, so that would be P2. Pent would be 5, so that would be O5 for pentoxide. Okay, and it's really that easy. And so what we did on the last slide and what we did just here, this is what your homework's going to be on overall. You're just going to fly through these. They're going to be so fast, okay? That's page 12 and 13 in our packets. So I'm going to clear. I'm going to move forward. The last thing we're going to do is a little compare and contrast of ionic and covalent. As I told you guys yesterday, you're not going to be allowed to forget the ionic stuff just because we don't like it as much, or it may be a little more challenging. We're still going to be using them because once we start putting all this together into making chemical reactions, it's going to be so necessary that we understand the differences and that we're able to go backwards and forwards. This is regardless of whether you're in a level course or a advanced course, or if you're an AP. It's just part of how we speak about elements and compounds and stuff. So we got to be able to work through this stuff. So go ahead and put a pause on there and see if you can recognize the differences in ionic versus covalent naming and writing. And then once you think you've got something, go ahead and put me back on, and you can check to see what you've got versus what I have. Okay, so you should have had enough time. We're going to go ahead and switch to the next slide, and I'm going to talk you through this. So with ionic naming and writing, remember, with our naming, we're going to simply be naming our metal and then our nonmetal and stick an IDE. When we name those metals, we always have to check to see if they need a Roman numeral. And remember, that equals the charge. This is so important here, guys, to remember that the Roman numeral represents the charge of the ionic compound metal, not the quantity, okay? And it's going to be really confusing because you just heard me talk about covalent and quantity, but ionic does not do quantity because they have charges involved. All right, so you could also have a polyatomic present, right? Those polyatomics are going to have more than one atom involved in the formation of the ion. That can take the place of a metal or a nonmetal. You just give their name, okay? And there's 13 of them you have to know, and those aren't going away, so keep learning those if you haven't yet. Once we are writing them, you're going to write the symbol and the charge for each ion, and then create the swap and drop, and then reduce if you need to. Reducing meaning like a 2 and a 2 cancel out to be 1 and 1, right? Or a 2 and a 4 cancel out to be a 1 and a 2, right? Super easy. Just keep them reduced on those. All right. So that's our ionic recap. Covalent naming. You name those first nonmetals as they are. Name this second nonmetal, stick an IDE. Notice that IDE, once again, that IDE on that second nonmetal never changes. It's always going to have the IDE ending, okay? And then the big difference here is that we're going to add our prefixes in, and that will represent quantity. Because we don't have them in ion form, we cannot swap and drop, so we heavily rely on the prefixes in order to represent how many we're supposed to have, because it's not as easy to put those together like that. Then when we're writing, we write the first nonmetal, we put a subscript in there for its prefix, we list the second nonmetal, and we put a subscript in for its prefix. All right, here's the important thing here. Do not reduce. Don't reduce on your covalent stuff, okay? Those numbers are supposed to be that way. So we reduce with ionic. We do not reduce with covalent. Please, please, please take some moments to ponder that, think it through, and commit that to your memory so that you will be successful, okay? And so I believe that is it. Yep, that's for tomorrow's stuff. Pretty straightforward lesson today. Please take a look at some YouTube videos if you're still feeling uncomfortable with the content, but give it a solid practice. Try that page 12 and 13, see how it goes.